Okay, today we are looking at the latest round of the Benevolent tournament, Ben or Ben, question mark, written by Benny Weber. I actually helped test this case, so the version I attempted, I think, was ever so slightly different to the one that went out, just with some clarifications around level 7, which we'll get to in due course. But yeah, I was very happy with my one of definitely my best performance in the tournament so far, so very, very happy with that. I'm going to try and replicate roughly what I did in the live case, although as usual, done some prep work, tidied it up, gone through a few case times so that this is as efficient as possible. So yeah, let's get going. That's enough chat for now. So let's hold on a second. I've left some of my workings behind, so let's just quickly undo those. I thought I'd cleared everything out, but it's only on the data table, so let's just go through this properly. So question level 1, what is the nth letter of the name? I realize you can actually do this as an array, so I can say mid of this text on this number and returning just one character, and then we get level 1. Didn't think that would be an array formula, would work as an array formula, but it did. Then for level 2, I'm going to import my lambdas just in case they aren't already, and I'm going to use my count occurrences, which is I'm going to count the occurrences of this letter in this text. It's not case sensitive, so I'm going to leave that argument blank, and when I fill those down, we get all of level 2 correct. Okay, level 3, this is where I'm going to start using my data table. So how many people match either the first or the last name of this person? If you match both the first and last name, count them only once. So let's work out what our first and last names are. So we're going to text split B1 based on a space. So that gets our first and last name. And then we're going to say, right, who matches? And this is where I'm going to do a little bit of data setup. So I'm going to give these names. So order, first name, last name, strictness. I'm also going to create a full name column, which is the first name and the last name. And then I'm just going to fill that to the bottom. I'm going to copy and paste that as values only, so we're not using up any unnecessary computing power. And I'm going to select all of this, Control Shift F3, and I'm going to give those named ranges. So I should now be able to say I want to filter the full name where the first name equals E4, and I'm going to do the same thing here, filter the full name where the last name didn't type in properly, equals F4, I think. Yep. And then I'm going to VStack those two lists, VStack that first name and last name, and then I'm going to unique those so that if any of them pop up twice, they get filtered out, and then I'm just going to count the number of rows in that, which gives me 14 for the example, and that works because none of these questions involve the two people whose names appear twice in the case, which comes up in one of the bonus questions. So got a little bit lucky there. If they'd thrown one of those in, I think I would probably have got that wrong because my unique would have got rid of the two entries of them. Right, level 4, you're given part of a name that appears in multiple name search for the first appearance of this nickname in the data tab. So what we're going to do is and I think we're told this is going to appear in the first or last name. So I'm going to search for whatever is in B1 in full name, and to help if I typed properly, and then I should have wrapped that in a is number to give me trues or falses on based on whether it exists, and then I'm going to filter the full names where trying to do this too quickly, where that is true, and that gives me all the people it's true for, and then all I need to do is just take the first row of that. So we get Ben Fisher for that first question, and all the rest is good. Okay, level 5, how similar are these two names to each other? So let's get the names firstly. So let's text split B1 based on comma, space, comma. And then what I'm going to do is just take one of these and work out all the possible strings. So I'm going to use mid. So I'm going to take the mid of this, and I want to do the fact that I can use two sequences. So sequences on the length of E4, and then also another sequence, but this time going out to the right on the same length of E4, and that will give me all the possible iterations, so every possible string within Johannes. So then I'm going to wrap that inside. What have I done? I pressed print screen by mistake, didn't mean to do that. I'm going to wrap that inside a unique, and inside a to-call. Close those brackets off, and we get all the unique ones. And then what I want to do is know whether any of these appear within this other name, and then what is the longest one. So I'm going to say is number search these strings in the second name, and I get trues and falses. So then I'm going to filter the strings where that was true, and then I'm going to sort by this list based on the length of this list, but in reverse order. So the longest one appears at the top. So AN is the longest. Oh, I didn't actually say that I had taken these. I haven't actually changed the case sensitivity. They're all the same as before, which I think for now doesn't matter. But actually, I'll tell you what I'm going to do. I think what I did in the real case was I lowered these all from the beginning, so I didn't have any issues. So I'm then going to just take the longest one of this, so the first row. I'm then going to say what's the length of that. In this case 2. My final answer is going to be, I need to say equals this divided by the maximum length of my 2 original names, which gives you 0.22, and then I times that by 100, so I'm going to round 100 times that, go to the end and round that to 0, and we get 22. And will that give me all correct answers? Yes, it does. Okay, how are we doing for time? Only just over 6 minutes and we're on to level 6. Right, level 6, similar letters. So what I did here was I grabbed the letters from the data tab, I pasted them, and then I also copied them again, but in the different order. So what I could then do is create these as 2 named ranges. This one we'll call letter 1, and then this one we'll call letter 2, and then we can do our substitution. So again, I'm going to lower the original name just so I'm not dealing with any issues of capitals and so on. And then what I want to do is find the substitution. So I'm going to substitute within this letter 1 for letter 2. And I get all the variations, but lots of them are the same. So I'm just going to say unique on that. We actually only get 4 real kind of variations, and now we need to find how many times each of these appear in the list. So if I was just searching one at a time, I would say, right, is number exists, not exists, is number search. Nope. What am I doing? Let me think about this. Let me just check my workings. Yeah, I didn't even need to use search. I was just going to use equals. So I'm going to say lower of, this is all based on first name, equals this. Oh, let me try that again. So we get a bunch of trues and falses, and we want to sum when those are true. So I get 1s and 0s, but now I want to do this on each of the rows. So I'm going to say by row over G4 hash lambda. My variable I'll just call row, which isn't always the best name because it's also a function, but should get away with it. And we get 11 Lucas with a K, 11 Lucas with a C, and then we're just going to sum this range here, and we get 22. And I'm going to point that to my data table, and we're all good. Okay, on to level 7, which I must confess I got a bit lucky on this in the test case. I'm still not really sure what I did and how I kind of got away with still getting most of it right, because what I actually did was I don't know, how do I explain this? I basically split into the 2 names, and then I tried every single combination of swapping out the letters, and then, but I didn't always swap the same letter in the names at the same time, which is actually what I think we should have done. So what I'm actually going to do is go back to level 5 and turn this into a lambda, which is what I did on the original, my first attempt, which helped me out with level 7. So I'm going to mark the input as the input cells. I'm then going to say, I actually just want to know the longest string. So I'm going to point that to the string. OA robots say generate lambda statement. And it gives me that. And I'm just going to rename this as names. So I'm taking the names as a kind of string with a comma and a space, and it returns me what is the longest string. So I'll then save that lambda as, and we'll call this longest string. Oh, I must have, in my preparation work, done that already, but there we go, updated it. So what I'm going to do is I'm going to say, right, what is the longest string of this? So we already know, so we know that there is an STE. Now we want to try all the different combinations, swapping each letter. So I'm going to say substitute B1, letter 1 for letter 2. So similar to what we just did before. And we get all the combinations. Let's move that out of the way, but quite a few of them are the same. So we'll just say, actually, we'll also, again, just to be on the safe side, we'll lower this before we do that substitution. and then we will take the unique of this. So actually there's only 8, but actually we don't want to keep the original one. So I'm going to use a lambda here called include exclude. I'm going to say include. This is my list I'm filtering. I want to check it against B1 and I want to exclude B1. So we always should drop by 1 because these are the actual things we're using. Right, now I want to find out what's the longest string with these pairs. So I'm going to say by row over this lambda. In each row, we're going to say longest string of the row. Close that all off, and we get all of our possible strings. So we see some of those longer ones appearing, and we want to know which ones of these are new, i.e. don't equal this. So again, I'm just going to say, let's actually, I could use include exclude again, can't I? So I'm going to include exclude on this list against this list. I want to exclude. So we only have 4, and that matches the example. These are the lengths, but we then are told that if it's found, we subtract 1.5. So these are the actual lengths. So I then want to take the maximum of those. So what was the best possible offering? And then I want to work out how that compares with the length of the original string, which is 3. So we're then going to take the max of those two. So in this case, 3.5. We're going to divide it by, and this is where I haven't actually done some of the work. So I'm going to say divide that by the maximum length of the text split of B1 based on a comma, space, comma. Close that all off. We get 0.4375, yet, which is good. So we're then going to say 100 times that, and we're then going to round that to 0 decimal places, and we get 44. And when we point to that, we get some errors because we've got some zeros. So somewhere there are no strings. So I think if I put my max here, I'm going to say if error, is this the most efficient way of getting rid of all of the errors? Most all of them. Then we get to 129, where I think we've got errors. Oh, because there wasn't even a string. So we're going to say this also needs to be an if error 0, I think. And there we go. And then we get all of our answers. How are we doing for time? 12 minutes. So let's go on to the bonuses. So bonus 1, what is the longest first name in the dataset? I got this wrong in the real thing. I just put 11 because that is the length of the longest one, but I didn't actually put the name. So I needlessly dropped 40 points, which would have put me very close to the top if I hadn't done that. But there you go, 11. So what do we want to know? What is the longest first name? So I want to know the largest, smallest. I want the range of values is the length of first name, and I want to return the first name, and it was Christopher. What is the most common last name in the data set? So I want the at equals at the most least of the last name. Gives you Martin. There are 2 pairs that share the same exact name. What is the highest name strictness? We'll go to our data. We will say, let's give us the most least of the full name. We get these 2 names at the top, Anna and Sarah, who appear twice. And then I want to say max ifs of the strictness, where the full name equals Anna Richter. We get 94. We just fill that down. We get 86, and the highest of those is still 94. So we go back to the case. 94. There is one letter of the alphabet used the most times across all names in the data tab. How many of the 1250 names do not include that most common letter? So first we need to work out the most common letter. So I'm going to say most least of the text characters of the concatenation of the full name. Should give me all the letters, and we get A appears 1580 times. So we want to know which of these do not have an A. So I'm going to say counter-currencies of this, no, not of this, of A within this equals 0 would mean there are no A's, so that's true. So Kenneth Green has no A's, so we will then wrap that in a minus minus, fill that all the way down, and in the sum we can see there are 287 ones, so there are 287 that don't have an A. And how many people's first names match the regular expression pattern of the author's first name? So we go up to their name, we grab this pattern, copy it, and the question is how many of the first names match that pattern. So we'll go back to data, we'll say regex test the first name based on that pattern, which we'll paste in, and we'll wrap that inside a minus minus. We get a 1 and a 0. We'll fill that down, and the sum this time is 30, so 31s, and so we put 30 in there, and we're all good. Let's just double check, all ticks across the board. Yes, we're all good. So how we doing? That was actually quicker than I thought it was going to be, 15 minutes. So pretty happy with that. Like, this was my best performance of that tournament so far. I think I would need to double check the numbers. I think if I hadn't messed up question bonus one by putting 11 instead of Christopher, I think I would have been joint top, but I don't know for certain. And I think, like I said, because I did a test case, I may not have done as well with what was the final version, because I presume some of the feedback we gave on level 7 and the wording may have affected what was put in there. But the key trick was realizing that when you change the names, you were changing the same letter in both names. And I originally tried doing it in different, so maybe I'll change the letter in one but not the other, and I ended up with lots of extra combinations, which meant I had lots of these, but in some cases it still meant you got the same answer anyway, because actually none of the new strings was longer or better than the original one, so you could kind of luck your way through it, which is what I think I did, if I'm honest. But yeah, anyway, yeah, lovely case, really liked it. For a text case, there wasn't as much regex as I might have expected, or maybe other people have used more regex. It'd be interesting to know. But yeah, I really enjoyed this case, and I'm sure if you're watching this, it means you probably did too, or you're about to have a go at it. And so yeah, great fun. Thanks, Ben, for the case. Thanks for the organisers, and I'll see you again next time.